You want me to say something? Like Mr. Gold?
Wow, he's such a great
teacher.
Wow.
I'm asking.
Finally, chair over there.
No,
Get this
because
time.
I'm not. I was actually perfectly fine. And all of a sudden she's like, bye. I'm like, is this zero? She's like, no. And then I was like, okay. She gets like this every single time or something. I just don't understand why she just can't get it.
You're literally you're 3-day weekend, bros. Hooray after the
16. So, anyways, are you ready with Joe or not?
Alright, Tim.
Joe already played it. Yeah. Okay.
With the things explained.
What are you doing? What are you doing?
Get your gas on too. Do you have yours, Brady?
No, I don't.
Table 3.
So, what else did she say about it? Did she say why, or did she just say bring it up? Oh, she said a crowd.
Alright, table 4. Table 5. Last table.
Tell Chelsea that.
No, it's quality.
Really? Who said that? Why did you go to that?
I saw you and your mom in school. I saw him. This morning, I was like, what happened? And I was like, high ankle sprain, drink that spot. She did not know that. She did not know that. The doctors did. They had x-rays.
Alright. So let's run through this one. I don't think this one was too bad. You guys can do pretty well on that. Again, I'm going to do table and person. Starting with number 11.
Like problem number 11. First problem I did.
How does the specific heat capacity of water compare to that of other common substances? Table 3, person 1.
I put water has a much higher capacity for storing energy. Liquid of lower specific heat capacity we're using.
Okay, first part made sense. No, that was good. First part was good. Second part, it was talking about how with cooling systems, if they use the lower specific heat, it wouldn't cool it as much. Number 12, why is North American West Coast warmer in the winter months and cooler in the summer months than the East Coast? Table 2, person 5. Right.
Because of the winds,
Okay, so,
like isn't like the westerly or
yep, okay, and where do the winds come from?
the west,
And what's west?
the water.
Yeah, the ocean. Number 12 or 13, why does a bimetallic strip curve when it's heated or cooled? Table 5, person 6. Or,
Because one side of the double strip becomes longer than the other.
good, perfect. 14, which expands most for increases in temperature, solids, liquids, or gases? Table 4, person 1.
Liquids. Gases.
Which one?
I don't know. Gases.
Yep, gases. 15, at what temperature is the density of water greatest? Table 6, person 1. Dylan.
The density of water is at 40 degrees Celsius.
Perfect. And number 16 is ice less dense than water because of its open. It is because of its open crystalline structure. But why is water at 0 degrees less dense than water at 4 degrees? Table 4, person 6. Yeah.
What number was it?
We are on 16.
Okay, I put the collapsing of ice crystals plus increased molecular motion with increasing temperature combined to make water most dense at 4 degrees Celsius.
Perfect. 17. Why do lakes and ponds freeze from the top down rather than from the bottom up? Table 3, person 5.
I put surface air is cooler than the water.
Yep, good. It is cooler. 18. Why do shallow lakes freeze quickly in the winter and deep lakes not at all? Table 2, person 6.
Okay. I'll get off this. The highest specific heat.
Okay, so explain on that.
Why would
So if you have a larger lake, does it require, when it gets colder, why would a shallow lake freeze faster?
less water?
Yeah, there's less water, so it requires more energy to come out of it. Does that make sense?
Yeah.
Yep. So it's just, you kind of knew that it was just because of less water. And that's just because the more water there is, the more heat it can absorb and give away. All right. The think and explain, I'm just going to look at when I collect it later on. So I'm not going to go over that now. But I'll talk about the online quizzes. I'll put it up on the board. How many of you still need to do quiz number 2? Okay. It was technically due today, but I'm going to grade them all at the end of the unit, so you can still do it. If you didn't do it by today, though, you just missed the opportunity to redo it.
So we can redo it tomorrow or what?
Yeah, you can redo it tomorrow. I grade them at the beginning of each class.
What about like if we redid quiz 1 today? Is it
Yeah, I regraded last week. Yeah, I just emailed it to you before class. All right, so this is chapter 21. This is the first quiz. So I'm going to put your numbers on the board. If you remember your number from the first quiz.
Yeah.
Russell Westbrook's knee surgery.
So this is your range reading number from the first quiz. This is your second go right. And this is the second time
On
around.
what?
So if you redid it, that's taking this into account. Your
So
second
this is
time.
a grade you'll get?
If you don't redo it again, this is your grade again.
Oh, we can do 1 again.
You can redo every quiz after every class. Again. I regrade all of them at the beginning of each class.
Did you redo it?
What about like if we take the beginning worse than we got on this time?
then that's the one I'll take.
Well, you
That
can
shouldn't happen though.
I'm
You
probably
should
not
know.
gonna go in those quiz too.
Because it tells you what you got wrong, so why would you say that?
Well, I don't know my email password.
Oh, yeah, I just looked on and off.
You don't have an email address?
No, I have an email. I just don't know my password.
Not quiz too.
So how do you check your email?
I don't.
Dylan, just make like a Gmail,
Because I put my phone in.
and then we'll know.
The ones I got right, so put the same answer, and then the ones I got wrong,
Wait for it.
So guys, I'm gonna need your attention for a few minutes today, and I'm gonna have you guys in groups anyway, so you can get your attention. But for these, I want to address the most common mistakes, which are these two.
Second one or the first one?
This is the first one.
Okay.
So these three were the most common mistakes. So which at the same temperature will cool slower on a hot day? Who was the person that just told me water had a high specific heat when we went through that?
That was Lindsay with her difficult answer.
Oh yes, that was you.
I remember that.
So water has high specific heat, and specific heat is how much energy it absorbs per gram in order for it to raise the temperature. So if water has a high specific heat, it can absorb a lot of energy before it raises temperature. So looking at this, which one of these has the most water? So then which can absorb the most heat without raising temperature? Water.
Melon.
So water. Yep.
No. Okay.
So then-
I should tell you a lie.
Watermelon would cool the slowest.
It's true.
It would be, it would give off the same amount of heat, but it would have to give off a lot more in order for it to drop in temperature
It's annoying.
compared to everything else.
How would you think apparently you're not.
All right, next one.
It's annoying.
When 1 gram of a substance loses 3 calories. All right. When 1 gram of a substance loses 3 calories, including 1 degree Celsius, its specific heat capacity is a magnitude of. Does anybody remember the units for specific heat?
Oh, it's like joules per gram of Celsius.
Yep, good job. So that's how we can calculate specific heat. If we go through the equation, it's the same thing. It's heat is in joules, mass is in grams, we have specific heat, which is what we solve for, and then change in temperature. If we divide the mass and the change in temperature, that's where this comes from. So we have, it tells us 3 calories, 3 calories, which is in joules or calories. Calories over 1 degree Celsius, and it has a mass of 1 gram. So what's its specific heat? 3. 3. So we've got that one. Last one is the last question. What releases the most energy? 100 grams of 100 degree water cooling to 50, or 100 grams of iron at 100 cooling to 50? Well, they both have to cool the same temperature. We just determined that water has a high specific heat, meaning it gives off a lot of energy per 1 change in degree in temperature. So now knowing that, which one do you think it would be? Everyone? Water. Yep. This one might be confusing because when you hold iron in your hand, it'll get really hot, but you're confusing temperature with the energy. It requires less energy to get that hot. Water requires more energy to get that hot. So that to get back to being cold again, it releases more energy back. For example, if you held something like iron in your hand, it would cool off pretty quickly. Whereas if you put a water bottle in your hand and it was really hot, you could put it in your bed and it would be like a heat warmer and it would last a while. Because it would keep giving off energy before it dropped in temperature. So those were just what addressed the most common mistakes there. And now again, I guess you should get those ones right. But you'll get another chance to redo this and I'll grade it at the end of the next, beginning of next class. All right, then here's quiz 2 for your class. There we go. So there's your number and the percent. And not everybody has done this yet, so if you didn't do it, you'll have to wait till next class. This one is out of.
Yeah, it's out of 11.
I think it's out of 2.
Actually, I did the email. It's out of 11.
I think that's out of 1. All right, and I'm not going to address these questions yet, since there's a lot of them. Instead, I'm going to address these next class, because we haven't gone over all this yet either. All right. So, today we're going to, also with your tests, those are graded. They're not put in yet, but they'll be put in by the end of the day. And since it's multiple choice, getting your test back won't really give you anything else than it went online anyway. So I'm just going to file those. But most of you, almost all of you improved. There were a couple that went down, but the most anybody went down was half a point. So almost everyone improved. Some improved by quite a bit. And now we're going to go on to linear expansion, which is the second unit, the second topic that the test is going to be on. We have heat and water, and now linear expansion. So I'm going to go over a few things about linear expansion, and then we're going to do a mini sort of presentation at the second part of the class, where all of you are going to get into groups and explain a concept to the rest of the class at the end, towards the end of the class. But for right now, we have linear expansion to talk about. And I'll start off with a demonstration. All right, I have a ring and a ball here. Right now they fit through perfectly. Talk in your table about 10 seconds, 15 seconds. I'm going to heat this ring up. After I heat the ring up, will the ball go through the ring? 15 seconds.
This music makes it so much more intense. It won't.
All right, what do you guys think?
It won't.
I think it will. I think it'll get bigger.
Well,
Yeah.
That was great. I think
Out when you get home.
all right, let's see.
You're smart. Good job, Doug. Keep the ball.
Yeah, heat the ball.
Then it won't.
Yeah, you need to heat the
All right. And if I heat the ball up, will it go through the ring?
No.
It'll get a lot bigger. It'll expand. What? See, Jordan, you're not even right. You're not even right.
I think you need to go get a bigger torch.
It didn't work. Jordan, put your finger on it, see if it expands.
Your face on
Alright. Second try.
That's so weird. You're a watcher. Shut up, dude.
Hold it on there until it goes, fits through.
What? It'll melt.
Yeah, it will.
Whoa.
Eventually.
Whoa.
Alright. Next one. I have this thing here. This is called the bimetallic strip. It has two different types of metals on here and here, on each side. That's why it's bimetallic. So, if I put this into the Bunsen burner, what do you guys predict is going to happen?
Then it's gonna curl.
Alright. So you guys kind of break
Jordan, that's you in 50. That's what you're doing for your career. 100 years, Jordan.
But I want to do a physical
100 years of your life, you'll be doing that for your career.
In 100 years, I'll start.
Yeah, you're right.
He's so.
You are.
You just said.
I said for 100 years.
You said in
of your life,
100 years you'll start your
that.
career.
No, I said half a meatball, Jordan.
You're
Alright.
not even a meatball.
So,
That's good, I'm not a meatball.
we know that we saw the bimetallic curve, and that's because all metals curve when they're heated, right? Right? No.
No, you did. I guarantee that. It has to.
That curved because of the two different metals. If it only had one metal, it would expand. But it was because it was expanding at different rates. There's two different metals that expand at different rates, that's why. If it was just one metal, it would just expand straight outward. So, continuing with this expansion thing, I have two short videos to show you. And then we'll get into the rest of the class, with you guys getting into groups. The first one involves a middle school boy, but just bear with me.
This is our video on the egg methodology. And what you're going to need is couple 3 or 4 minutes. Any flour, make sure you get it.
Yeah, I think that's what we did.
And paper to help. Start with the science fair. You're going to stuff a piece of paper in that. Let's start with 3 this time. Try to get on the piece of paper though.
Pretty demanding. It's a little cute. I don't see his face.
Yeah, got it. Okay. And now, well, okay, and now you're going to put either thin side or fat side. You're going to put the egg in, and you're going to seize, and it will be sucked into a large liquid.
So weird.
Yeah, sometimes you suck it back out too.
This is how long to do that.
Blow it out.
Wow, that is solid. Now I'm going to put this.
Yeah, I mean, this is me.
Put it down the line.
Oh,
Oh,
egg.
hours.
Oh my gosh, it's like cutting the egg.
Whoa! And that's it.
Is that Justin Bieber? He literally.
Yeah.
Is that Justin Bieber?
It looks like him.
Whoa.
Someone else thought that too. Alright, so I think you guys did some chemistry, right?
Yeah.
Okay, so who can explain why it got sucked in?
Does it burn up all the oxygen and turn it inside?
Expanded.
It burned up all the oxygen inside the bottle.
Okay, it did. It did burn up all the oxygen. And what else with the temperature difference? What happens? With the expansion and contraction we just saw there. Yeah, so you could think of the hole widening, and that's if you're heating up the actual hole. But we're just heating up the air inside. So if we're heating up the air inside, then it starts heating up, we put the egg on top, then the match burns out, it starts to cool down. So then what happens? What do you think, Erica?
I don't know.
So if it was hot inside, you put the egg on side, the match burns out, it starts dropping in temperature. If heating up makes it expand, and dropping in temperature would make it. Yeah. So what happened was, we had this bottle, the match was in there, heated up the air inside. Air escaped through the top because it expanded. We put the egg on top. When it cooled down, it started contracting again, and then I had to pull the egg down with it. So that's similar to the thing we just saw over there with the hole expanding. It's just a gas. And gases we learned expand the most. So that's one demonstration of a gas expanding. The other one is over here.
What would happen if we put the ball into a glass of cold water and through the
liquid nitrogen. If you put liquid nitrogen on a balloon, the atoms move slower, need less space, and this is called contraction. When the warmer atoms from the grass and air hit the balloon, the atoms inside the balloon heat up and they expand.
That was cool.
So that was just a helium balloon. And it showed you that when they cooled it down with liquid nitrogen, which is incredibly cold, the gas contracted inside the balloon, making it more dense. Now it was denser than air with all that contraction, and it sank. Once the liquid nitrogen was removed because it was on the ground, it started to heat back up again to room temperature, expanded again, was now lighter than air and started floating. So there's a few different examples of contraction and expansion. A few other ones that you can take this as practical physics. If you've ever had trouble opening a jar, you can't get to open, especially with the old like metal type of lids.
Pickle jar?
Yeah, like a pickle jar. If it's glass with a metal lid, the metal lid is too tight. You could just open up some hot, turn on some hot water, put it in there, the metal will expand, and then you can just easily turn it off. So now there's an example where you don't have to struggle with a metal jar anymore. Some other ones are with sidewalks. If you've ever wondered why sidewalks aren't continuous and they're broken up into little squares, that's because when it gets really hot in the summer, the sidewalk expands. So we have to have the little gaps in between the tar so that it pushes together and it won't make cracks in the sidewalk. But sometimes it still expands too much and cracks occur anyway, and that's why you see cracks all over in sidewalks. But that's why they need to be separated. And then the last one is with a ping pong ball. If you have a ping pong ball and you squeeze it too hard it gets a dent, instead of throwing it away, you can either turn on some boiling water and put it in the boiling water, and it'll pop it back out from the gas expanding. Or you could just put like a little lighter underneath it if you hold it far away enough, and that should pop it back out
That's
too.
good enough for college. Just kidding.
Is that appropriate?
Yeah, I'm a ping pong master.
So now I'm going to put you guys into groups, and I'm going to have you take about 10 to 15 minutes, probably 10 minutes. I'll give you guys 10 minutes to read about these specific topics, and then you are going to come up to the front here and present it to the class. These are the last 4 topics we need to know before the test. So the next class on Friday, on Wednesday, is going to be a review day of everything. And then the test is going to be next Friday. I'm going to have both of you two groups together, those two tables. Turn to page 413. Read about the high specific heat of water and present that to the class, talking about coastal areas specifically. All right, these two tables here, 3 and 4, are going to be talking about why 4 degrees Celsius of water is most dense. And that's on page 319. And then the last two tables, I'm going to talk about why/how a lake freezes. On page 321.
All right, Wayne and Katie.
No, you hungry now.
And there's one seat. Okay.
Jordan, your little
All right, so take about 10 minutes, and then I'm going to hit present.
You're that free table. Just one. Wait, so I'm over there.
That's why you guys have to college right. Okay, so are we just like teaching class? Okay, Jordan, what did you say? Okay, so at 4 degrees Celsius, so
When you guys present though, make sure everyone in your group has something to contribute. At least a sentence or something.
Oh yeah, okay, so I can do that, I'll probably do it. So graph, that's anything is graph and I'll something. Okay, so water has yeah, so hey, do you want to say that since you brought that up? Sure. So again, I literally have a map, so yeah, and grade descent, which makes grade descent. I'll put on the paper 4 degrees Celsius. Smallest volume. Which makes the grade Celsius.
Also, be prepared for questions from the audience, including me. So I might ask you questions.
Okay, so
and I could address anybody specifically. So you all gotta know.
Oh yeah. Okay. So everybody's put that in the parentheses. Wait, where's that at? It's right here in the parentheses. And then Lindsay, do you want to say that? So I'll just put ice flows. Or you can just give an example of this, like how ice flows in water. Oh, should we say, like, right before that, the same amount of water has its largest volume and smallest density in solid form ice, and then it's like, remember, ice. Should we say that right before it? Yeah, I'll put it like on the mirror, okay? So. You understand this? I'm putting an amount of water, or wait, a given amount of water has the smallest volume at 4 degrees, which makes it the greatest density. Okay, then I'm going to say at, wow.